Hello. Hope you guys are doing great today. We are going to take a minute to go through some problems that will help you prepare for your Unit 2.4 exam. So this is some beginning applied problems with right triangle trigonometry that you're going to be working through today. And what I'd like you to do is I'd like you to take notes on these problems and work through the calculations. The best thing to do, I believe, would be for you to try and work through the calculations and try each problem prior to listening to my explanation of each. So perhaps as I get started on a new problem, you pause the video and try it yourself first, and then see how you did on your own by watching me work through that same process after you do it. All right. So I'd like you to also, my geometry students, be ready to turn in the notes that you take today on this video with your exam this week. So try to just be careful about making sure you try each problem. And if you have any questions, we can address those before you take your exam when I see you in person. Okay. So here's the first little scenario, and I apologize, the numbers on the diagram are not super visible, but we can kind of draw a secondary diagram of the situation. A cat sitting on a pedestal above the ground, looking up at an angle of elevation of 52 degrees. She sees a lizard on the ceiling. So I guess this is supposed to be a little lizard on the ceiling up here. And this little angle is going to be 52 degrees. Looking down at an angle of depression, so remember, an angle of elevation is from horizontal going up, and angle of depression is from the horizontal going down. So of 35 degrees, she sees a rat. Oh my goodness. Who to chase? We just don't even know. Okay, so there's my 35 degrees right there. Given the lizard is directly above the rat, kind of as you see in the diagram, and the horizontal distance. Now, a lot of problems talk about the horizontal distance. So that means the distance from the base of the pedestal to the rat, okay, is 5.5 feet. Okay, that does not mean that from the eyesight of the cat to the rat, it's 5.5 feet. It means the horizontal distance. And so we're supposed to find the height of the ceiling given all this information. Well, we really have two problems to solve, right? We really have two right triangle trig problems to solve. One of our right triangle trig problems is from the cat to the lizard, and the actual height from the ceiling to this point. Let's call it x. Just that little piece right there. We do know that this distance, the horizontal distance here, is going to be the same as the horizontal distance on the floor. So we know this is 5.5 feet. This is kind of one of those step 1, step 2, step 3 kind of problems. All right. So we know this angle is 52 degrees, and with respect to this angle, we want the side opposite. We know the side adjacent. So if you chose to use tangent of 52 degrees, you have chosen the correct trig function for this problem. Okay. So we know we're going to cross multiply, so we actually get x times 1 is equal to 5.5 times the tangent of 52 degrees, and that will help us to find that first little piece of information that I need from top to bottom. And I'm going to go ahead and plug that into my calculator, and maybe you guys have already plugged that into your calculator. Making sure you're in degree mode, super, super important. And let's see what we get. So 5.5 times tangent of 52, I got 7.039. So if I rounded to the nearest tenth of a foot, it would be 7 feet. Okay, there's my step 1. Here's my step 2. I have this other triangle, right, that looks like this. From the cat over, it's 5.5. And then I have this distance down to the rat. and that's what I'm trying to find here. Let's call it y, and I know my angle of depression is 35 degrees. Well, this ends up being another tangent problem, right? Because we're not interested in the hypotenuse at all, so we're not going to use sine or cosine. We want to use tangent. So this one is going to be the tangent of 35 degrees. Just going to make these fractions equivalent. And let's see, opposite over adjacent. Okay, and again we get 1 times y is equal to 5.5 times the tangent of 35. You guys probably already have this answer written down, so now you're just double checking to make sure I do it right. Right? Guys out there, you got this. Okay, 3.85. So to the nearest tenth, maybe 3.9 feet. Okay, so now we have x and y, and what is going to be our last step? What do you guys think? All right, so our total distance, you're right, we need to add them together. So our total distance, I don't need that to be a y, is going to be 7 feet plus 3.9 feet, which is going to give us 10.9 feet. Okay, a little bit of a high ceiling. Not too bad. Those numbers work out pretty good. Okay. Hope that one went very well for you. What I'd like you to do is, I'm not going to talk you through the step 1, step 2, step 3 on this next problem. I want you guys to try it. I'm going to pause the video, and then it's just, the answers are just going to appear, and you can, of course, pause it to check out my work, but this will move us along a little bit. A similar problem, but I want you guys to give it a try and see how you do on your own. All right, so here is the next problem. The angle of depression from a plane pilot to the top of the cliff is 63 degrees, okay? So an angle of depression of 63 degrees. And what else do we know? The angle of depression from the cliff top to a boat in the harbor is 12 degrees. I don't think our picture is to scale, so go with your numbers if you're drawing a picture similar to the one you see on the left. If the horizontal distance from the boat to the base of the cliff, again we have the base of the cliff and we have this idea of a horizontal distance is 2 miles. So I do want to label the diagram for you here. You are going to have a 2-mile horizontal distance. So that means in this triangle, this is 2 miles. That means this is 2 miles, right? We have this knowledge of your information here and our angles of depression. Now, this one's a little bit different. I do want to get everything into the right place with you or for you. So we're finding the distance from the boat to the plane. This is what you need to know about angles of depression. We haven't worked with these a lot, but what ends up happening is this angle of depression from the plane to the top of the cliff is actually, and it isn't to scale because I changed it a little bit. If this angle of depression is 63 degrees, because we have parallel lines cut by a transversal, that means that this angle here at angle 2 is 63 degrees, right? So if you redraw this, okay, and I'm going to redraw it just here for you to get you started. You can use your 63-degree angle here and your 2 miles to solve for x in that first right triangle. Then in the second right triangle, what you're going to have is you have another angle of depression. Well, what happens with this angle of depression right here, this angle of depression right here at angle 3 that you see in your picture, it's supposed to be an angle of depression of 12 degrees. The same thing happens. You have horizontal parallel lines cut by a transversal. This is like when we were doing our dance-dance-orama in the hallway, right? Alternate interior angles mean this is the angle that is 12 degrees. Okay, so this picture looks more like coming back this way, right? See if I can draw it for you. 2 miles. Oh, my picture is way off. Let's at least draw something that's a little bit more like 12 degrees. Okay, so this is 12 degrees. Here's your right angle, and maybe you're trying to solve for y. Okay, you guys solve for x and y, and then again, what we're trying to figure out is the total distance from the plane to the boat. So when you come back from solving that, the answers will be ready to go for you to check your work. Boom, just like that, magic. All right, so hopefully you got 4.325 or some approximation of that. I rounded here to the nearest tenth and just to the nearest thousandth here, just to kind of keep some other decimal points in. You guys might have rounded a little differently, but basically your process should have been the same, okay? And that brings us to our next problem, which is going to be kind of taking a look at kind of a true or false scenario, okay? So this next problem, we'll just call it problem number 3 for your notes, since it's the third problem we're working on. And the question is kind of true or false. Can these numbers actually be true for this triangle, right? With 5 meters along this side, 84 meters along this side, and an angle of 11 degrees. Well, gee, how could we test that out, right? There are a couple different ways. We could actually use tangent to find the value of this line given a vertical height of 5 meters and an 11-degree angle. We could do that. We could actually just set up the proportion and see if it's actually true. I think that's one of the easier ways to kind of work through a problem like this. What if we just said, okay, let's figure out what the tangent of 11 is. I'm going to use my calculator to figure that out because it should be equal to opposite over adjacent, right? It should be equal to 5 over 8. And I'm going to go ahead and figure out that ratio as well. So if I take the tangent of 11, on my calculator, tangent of 11, I should get a decimal value that is equal to 5/8. So let me try that. Let's see, 0.1943. Okay, well, let's try 5 divided by 8. 5 divided by 8. Oh, goodness. This is 0.625. Wow, those are not the same at all. All right, so we're going to have to fix something. Let's see. It says, so this is going to be like a huge false, right? Because the tangent of 11 does not equal 5 over 84. Oh, wait a minute. Ha! Let's at least make it 5 over 84. Sorry about that, guys. Okay, I'm not going back. I'm just going to redivide here. 5 divided by 84. That's going to be closer. Oh, but not close enough. What do we got here? The actual value, 0.0595, let's say. Still not the same. Okay, so no, those are not going to be equal. So it says, if not, can you change the horizontal length so that this triangle works? Okay, so we're making a change here. So the horizontal length is this piece. So let's go ahead and just label this with a new variable. Let's just call it, we know we don't want it to be 84. We're going to kick that out. Okay, the 84 is out, and we need something else that will be in that makes this true. Okay, so we're doing a lot of work with tangent. I hope you guys are ready to do work with sine and cosine as well for this particular exam. But again, we're going to be using tangent, right? Opposite adjacent to my angle 11 right here. Let's find something that actually works. Okay, so let's say tangent of 11 is equal to my opposite, which is 5, and let's get an adjacent side, which is actually going to make our equation true. Now this is a different one, right? Our unknown value is in the denominator now. We're still going to cross multiply, okay? We're going to cross multiply this way. It's equal to x times the tangent of 11. And in this problem, we are going to actually be dividing by the tangent of 11. So 5 divided by tangent of 11 is 25.7. 25.7. So I have to change this quite a lot. Wow, that was way off. All right, here we go. So we'll just say, let's see, make sure I got that. 25.7, x would have to be 25.7. Okay, so I hope that went pretty well for you. Please don't forget that the next couple of problems, I'm going to go ahead and just give you an example, and I'm going to work through one of them with simplifying square roots, and the other also with simplifying square roots, just to kind of push you guys in that direction. But if you need to use your calculator to work through problems with 45, 45, 90, and 30, 60, 90 special right triangles, we can do that as well. Okay. So on our last two questions, I think is what I have for you here, guys. We're just going to go back to those notes that we took in class, and let's just try a couple. Okay, I'm going to make this 20 centimeters long, and we are going to figure out the area and the perimeter. Great time to stop the video. Try it on your own before moving forward. Okay, I'm just going to be moving forward. So this is going to be 20 divided by root 2. This is going to be 20 divided by root 2. When I find the area, it's going to be 20 root 2 times 20 root 2. Okay, and I'm going to leave all these calculations in terms of my square root of 2, just so you guys can kind of see what happens. So 20 times 20 is 400. The root 2 times root 2 square root of 2 times square root of 2 is square root of 4, which we know is going to actually be equal to 2. So your area on this particular problem is actually 200 square centimeters. Boom, and you're done. Perimeter, we have 4 of these sides that are all equal because it's given that it's a square. So I can either add up 20 root 2 4 times, or I can say that's the same as 4 sides times 20 over root 2, which is going to be 80 over root 2. And this is called rationalizing the denominator. So watch what I'm going to do here. I'm going to multiply both the top and the bottom by the square root of 2. I end up with 80 root 2 over the square root of 4. But remember what we talked about, that square root of 4 actually is 2. And then because 80 is even and can be divided by 2, I'm not going to divide out the square root of 2. You can't cancel from underneath the square root right here. Don't do that. But this 80 divided by 2, because they're both integers and they're tied with multiplication here, you can make this 40 root 2. Okay. Perimeter, and that would be centimeters. And area. Okay, next, perimeter and area. Last one. Woohoo! You're almost there for this Monday morning. What if I told you the altitude, okay, of this equilateral triangle? Whoop. Now get back on the, there we go. triangle, we'll abbreviate that with a little symbol there, is, let's say it's 6 root 3. Okay, if you know that, if you know this is 6 root 3, this is where everybody should be, hey, stop the video. I have enough information now in my equilateral triangle to figure out the area and the perimeter. Do it. Stop the video, try it yourself. Come back to me when you're done. All right. So now you're done. Here we go. This is going to be 6, which makes the entire length 12. So our base is 12. All of our sides are 12. That makes our perimeter, oh, and what should we use? Just units? 36 units on my perimeter. Adding up all the sides. Don't forget the area of your triangle is going to be 1/2 the base times the height. So we're going to have 1/2 times 12 times my height, which is the altitude, 6 root 3. And that is going to be a final answer of 36 times the square root of 3. You may have changed this and done 1/2 times 12 is 6, and then you may have multiplied it all together to get a decimal. And if you did that, let me just find out what that would be on my calculator too, so you guys know. If you did that, that would be 62.4 square units. Oh my gosh, look at that. The bell's ringing. It's time for class to be over. And your video is done. So use your remaining time. Your class may not be over, all right? It may be over, it may not be over. If you have some remaining time in class this Monday morning, go ahead and make sure that you are doing things like completing any missing assignments. And if you have a chance to try the extra credit assignment that I left for you, that would be awesome as well. All right, guys, have an awesome day. I'll see you in class. Don't forget to bring your notes.